Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to the website at www.arcweb.com.
Hello, I'd like to welcome everyone today to our podcast. It's entitled EcoStruxure Power and Process and its role in process electrification. The convergence of power and process is a trend that I've been following and enthusiastically endorsing. Historically, electrical power management and automation systems were designed and operated independently throughout the plant's life cycle. This separation made sense in the past, but with digitalization and IoT have enabled this integrated connectivity between power and process domains. And the timing is perfect in conjunction with the trends of decoupling software and hardware and software automation and software-defined automation, along with AI's rapidly growing influence, of course. Schneider Electric has been at the forefront of these trends, and we are very fortunate today to have as our special guest Manishi Tiwari. She's a Senior Director of EcoStruxure Power and Process Programs at Schneider Electric, who's helping to drive this convergence in the market. Thanks so much, Manishi, for being here today.
Thank you, Craig. It's my pleasure. Thanks a lot for the welcome. And as you rightly just mentioned, this is one of our key topics, very close to Schneider Electric's heart, not just now, but it's been there for a while. And I'm very privileged to be able to drive that for Schneider. Yeah.
I think you're certainly the perfect person to have in that role. So tell us a little bit about yourself and your role at Schneider Electric.
Yeah, sure. That's good. So I've been working with Schneider for about 17 and a half years now. And if you want to divide my career journey so far, broadly, it will be 50% into energy management domain and rest of the 50% should be in the process automation domain. So I'm a process automation engineer. I worked with Emerson before I joined Schneider, but since I've joined Schneider, I've been working onto their energy management portfolio, into sales, into R&D, marketing type of profiles. Until recently, 4 or 5 years back, I came back into process automation business. And it just kind of connects the whole dot. And that's why I'm doing this role for Schneider Power and Process, because having seen both sides of the world, behaviors of the customers, and especially now on the trend, amazing trends that we are seeing overall in the world, in the market, I think my role in Schneider is really about how do we ensure there is the right value proposition for the customers, and encompassing what Schneider has been able to offer with the portfolio of energy management, industrial automation, and services and software altogether. For combining, integrated approach for the customers and driving this kind of discussions with not just end customers, but EPCs, with also our partners in between the ecosystem like OEMs, etc., to help drive the mindset change, to help them solve the real-time issues regarding, those isolated systems that you just mentioned, and how can we work further together hand in hand as the technology partner to them, to show them exactly how it's done.
That's great. So not only are you certainly managing the space, but you've had career process and power convergence as well. So yeah. I think that's worked out. So you makes you the perfect person to be running this initiative at Schneider Electric. And speaking of that, Manishi, what do you see as some of the mega trends that are kind of transforming the industrial landscape, that are kind of driving this shift to power and process convergence?
So I think we can all agree to this point that there is something which has drastically shifted in the past couple decades. A, the way we look at energy has changed, and B, the way we look at digitization has changed, right? And the way we look at energy has completely changed because it's energy production, the consumption, the factors like urbanization, population, AI boom, etc. Everything is basically driving this mega trend towards the way we look at energy. If you just want to talk about energy alone, it's not enough. We really cannot talk energy without talking about climate. Energy production and consumption account for 80% of global carbon emissions, and it's huge. And that's why 81% of industries are now thinking to take a power of two approach, meaning identifying secondary sources of energy that are not just clean, but also effective. So examples like solar, wind, etc., which are definitely growing faster than other energy alternative sources. So this is basically driving the next mega trend, the reliance or adaptability towards the renewable sources of energy into the core processes. Actually, in some regions, it's already outpaced fossil fuels in power generation because electricity from renewables is up to 95% efficient, far better than coal, oil, or gas. And not just that, cost of producing energy from renewables has also gone down significantly in past couple of years now. For example, cost of producing wind has gone down to 70% in some geographies, and solar even more. So these are great drivers towards, acknowledging the fact that the energy production from renewable sources is just not an obvious alternative, but a very, very pragmatic choice to bring more processes powered by electrical sources. So, and the third mega trend is about the surging demand of electricity that we can all witness now. And it's not just coming from, as I said, growth of population or urbanization, but the big factor around the boom of AI. And to feed those data centers, we need an enormous amount of electricity as we go forward, right? So, and just to give you the context, the grid will need to generate 61% of more power by 2040. That is from today, which is about 2023, if we talk about it, 28 petawatt hours to 45 petawatt hours in 2040. That's huge. I mean, just to imagine that kind of supply of electrons to not just feed the residential, the commercial, but also industrial space and domains is going to be magnificent amount of work for the energy suppliers, right? And not just that. It's not just about availability of electricity, but also resilience, because grids have to withstand those extreme weather conditions sometimes, security threats. There is always a change of peak demands based on the climate, based on a lot of geopolitical scenarios which keep changing. So just to keep the pace and meet future energy needs, it's always essential that companies they have to keep innovating. They have to find ways to survive this, and also ways to differentiate in front of their investors. And that's where I see these mega trends are pushing those industries towards, being those differentiated or just be able to survive on a day-to-day basis.
Oh yeah, and I think you really defined those so well. I mean, especially your point regarding the fact that when the old theory of renewables was it was much more expensive, but your point of how sometimes the costs are now competitive or less than fossil fuels, and I think getting that message out is so critical. And the other point that you brought up, which is so critical, is the whole issue of being operationally resilient, and making sure those grids can withstand, climate issues or cybersecurity issues, which brings me to the next subject, which is, kind of like the industrial challenges that you think are kind of, continuing to drive these transformations, and how you think that customers can best cope with coming up with solutions for these challenges, and seeing how the convergence of power and process, is helping the customers cope with those challenges that they face.
Yeah, I mean, I would say this is gonna be not just a choice, but it's going to be an expectations from now on, that how industries are imbibing or incorporating this kind of changing scenarios, and a lot of unseen, unprecedented situations that keep occurring from time to time basis. How do they face that and bring still bring innovation and still manage to maintain their profit margins. Industrial processes are a very good example to understand this, because if you just simply talk about bringing electrification into their scenarios. If you talk about many years back when electricity was just considered to switch on the light or fans or ACs in those big industrial complexes, right? And the processes were really driven by just gas, coal, etc. Now, we are saying that electricity will become part of those processes, and instead of the grid, instead of, let's say, gas, coal, etc., your processes will be fired by electricity. This is very new scenario for industrial landscape, right? And it's exciting and definitely more rewarding. So one of the key trends, or one of the ways industries can face this kind of a challenge or scenarios, is basically to shift towards more electrification. And just to give you again a context, as of 2024, only 5% of industrial heat has been electrified, but 60% would have been electrified with technology that we have today. So from 5% to 60% as of 2024, there is a big gap, as you can see, and hence there is a big opportunity as well for us, a big window for technological changes and mindset changes that is required for companies to adapt. So it's not happening. It's actually happening now as we speak. We are seeing major shift towards electrified industrial processes, like from boilers to heat pumps. Today, industries are facing mounting pressures to evolve faster and more sustainably, right, at the same time. So process electrification is not just a key driver towards their net zero ambitions, but also due to the evolving energy supply landscape, which can be very unpredictable because renewable sources are not always available or permanent. They still need to find ways to be flexible, adaptable, etc. But having said that, if you weigh pros and cons, still the benefits to electrify the processes always oversees any other drawbacks that you can imagine. So for industry, energy and automation will and has to be integrated, because, as I said, energy is no more just to power up some assets in the industry. It's really to drive the processes. It's going to be the word itself, the process electrification word itself has the process part and the electrification part. They are intertwined already. So but it's not going to be easy for sure. As you said, the challenges they will face is going to be not really some unseen. The good news is the challenges they will be facing in order to move towards more electrified processes are not unseen or unknown or unprecedented or unsolvable, but we have done that. We have been there, we know how to do it, but it's more about solving those extra pieces to the puzzle, because, as I said, renewable is not permanent sources of energy. So there are always going to be questions around when is it smart to produce energy, when it is smart to consume it. How do I guarantee reliable power at all times? Because weather is not reliable enough every time. You can have a weather forecast on one side, production on the other side, and then you can make a decision now. Should I be consuming more or selling back to the grid? As I can see, there's going to be, good sunlight next week, or it's going to be raining, so let me produce more. So these are some decisions which has to be taken and accounted for as more and more we incorporate those electrification scenarios within our operational production landscape. But these are very, very legitimate and I'll say important questions to be addressed. Because energy management is no more an isolated island, it works only when it is integrated with the production and throughout the entire life cycle. Here, I'm not just talking about at the production, like at the layer when it is at the operational stages, but right from the beginning, at the design stage, all the way to build, to operate, and to maintain stage, the energy management is going to pair along and work together in an integrated approach. And that's the key, like the mindset, the understanding of CEOs of these companies, the EPCs that are designing this, the investors who are funding it, that mindset, that understanding that we know we need those systems to work hand in hand together is very, very crucial, as many design decisions have to be taken early on. Because I think, as I would assume you would agree, like that it's not going to be in the future. It's not going to be about, you're not all smart enough just because you're saving more power. The more differentiation would be around how intelligently you use that power to improve your profits or to manage other targets. So it's about using that power to your benefit is more important than just saving and, just doing day to day around it.
Oh yeah, absolutely. I mean, like a clear example used to be that people would just say, okay, if I can save 10% of my power, but if you're doing a solution and you're running it during peak times, if you could be buying that power and off-peak times, you're saving far more than the 10%. But before the days of having the convergence of power and process, the systems didn't speak to each other. There was no communication. So you couldn't make those decisions of when to buy, when to consume, and then at the same time be scheduling your manufacturing processes to maximize, let's say, the most optimum time when energy is either available or at the lowest rate. And just by having that ability to communicate, this is where the convergence of power and process today, is so essential, because you can't make the right manufacturing decisions if you're not making the right power decisions.
Yeah. Absolutely. Like you said, these worlds are not just designed. Like I remember I'm coming from, as I said, long back when I was into process automation field in Emerson, like the way the designing of these systems were done in a way that their data tags were named differently. Their workflows were very different. Engineering workflow, engineering stations were different. The names of all the IOs modules are different in the both worlds. The switches, the network. So they were designed really not to interact with each other. That's the purpose was only to make sure wherever there is a physical link, like a motor shaft, etc., then the integration happens. Otherwise, these systems are not supposed to be talking to each other. They are supposed to be isolated, and they're supposed to be running on their own. So that's a big shift. Now we are talking about, hey, they are not supposed to be in isolation. They are supposed to be integrated. It's a whole change we are talking about here.
I know. I remember back in the days when I was with the Foxborough Company. And we would go in and certainly, proposing, certainly a DCS for, such as IA series back in the day. And if you could never even mention that could be used on the power side. It had to be a separate DCS for power. And it was the two, so we always, we always spend so much time today with IT, OT convergence. But this convergence of power and process is equally as dramatic. And I think sometimes people that haven't gone back, that don't go back to those years when it was completely separate. But we always used to wonder, what if these systems could speak, but it was always blasphemy to even make that suggestion. Exactly. But today, you cannot be competitive in a global economy, manufacturing, if you do not making the right decisions with your process and power. Never mind the fact that if you're in an environment which is so continuously being more AI driven, how are you going to be able to manage the power that it takes certainly to run all those AI agents and deal with all the large language models? Yeah. If you don't have the power, you don't have AI.
Yeah. Absolutely. Yeah.
And I think that's why, when I think of like how Schneider Electric is equipped to kind of tackle it and be that technology partner for customers to address all the mega trends that you very succinctly defined, to address all the challenges that you succinctly defined, and really kind of be that partner to really help them, and using platforms like EcoStruxure, Power and Process to kind of help along. Can you please tell us a little bit about how you see, why you think Schneider Electric is, let's say, the ideal technology partner for customers to be going through this power and process conversion?
Yeah, that's my favorite question. Yeah, so for sure, like our portfolio, as we all know, is always covering power and process world with energy management and automation solutions. And On top of it, we have software portfolio and full advisory services portfolio to manage customers end to end. So there are, plenty of, as I said, offering tools that are today working with renewable energy sources and helping customers to bring that energy mix into their production levels. So if, for example, like hydrogen, like if you want to produce hydrogen, you really need to understand how an electrolyzer works and what its impact is. And we in Schneider can perfectly combine and integrate both sides of the coin with hardware, with software, and above all, and very importantly, deep expertise. Our expertise on this area has been there from ever, because as you said, it's not by chance or coincidence that we had expanded our portfolio all the way to not just electrical management or industrial automation, but also to the software side, because we know that how energy and all those mega trends are going to shape up the decision making of the customers eventually. So and like we all we talked about it, like in the past it was just easy, just you plug in the power cord and your production ran at affordable cost. But it's no more like, this is not the situation today. It's very more complex, and we understand that as Schneider. So how do we do that is with our, what we call in Schneider is EcoStruxure power and process approach. It brings together the worlds of power and process in a single unified system that improves energy, resources efficiencies, reduces cost, of course, because customers can make more impactful decisions very early in the design stages, and at the end of the day, to manage not just overall performance across the life cycle, but also ensuring, we cover the full flow of information data at the later stages of operational and maintenance cases. That's very critical for us, because I think most expensive cycle of any industry is at when they reach the operational stages, because that's where the profit margins are generated, right? So we want to make sure that whatever is your journey has been, we are making sure you can make those decisions based on how you want to see your operations tomorrow. For example, at the design stage, it starts with taking site requirements, assessments, and then creating digital twin models of both electrical designs with ETAP, and then using these models to give considerations around the process designs. So we start with developing those digital twin models of both electrical designs and process designs with Aviva and ETAP simulation models. Then in the build stage, it starts with having common engineering workflows. So once we have information with us, it's then much more efficient for us to discuss our engineering workflows together, because we can see the data from both sides. The digital twin model not just helps in unifying engineering workflows, but also very importantly, these models can be used to train the operators into real-time basis, because we generate what we call as co-simulation, meaning a simulated environment for the operators where they can actually simulate before operate. They can try and test different scenarios like motor start stop, shutdown scenarios, and while managing those complex flow of electron supply chain. So those are what if scenarios. So, and customers can make those important decisions in terms of what should be the right size of the transformer. If tomorrow I need to increase my production to X level, or how should if I downsize my transformer, or if I change my production level, how is it going to impact the pump? So these are some scenarios they can really play along in a simulated and a safe environment before they can make very heavy duty decisions that can impact their CapEx and also OpEx. So we want to make sure that information starts very early with you, stays with you, and move along as you go. It doesn't matter brownfield or greenfield, because for us, we deliver EcoStruxure power and process approach for any type of scenarios, and make sure that customers are fully equipped with the right statistical model to build the system. In case it's a greenfield, it's much more straightforward because it's like a blank slate for us. We can start. But with brownfield, it's more complex, but the beauty of brownfield is that we have already enough data from the past couple of years to help make more intelligent statistical models. So we can work on both sides, and every customer working on electrification or optimization benefits from this integrated approach. We have seen that, we have done that in a few cases already, and we see the tremendous empowerment that it has given to our customers. Brownfield, I must admit, they are not as flexible. Most of them, they are built 20, 30 years ago. The flexibility doesn't exist. So you just cannot change immediately a gas-powered boiler or furnace into electrical power. There are so many elements to consider and so much complexity to consider. And we are fully equipped. Like I said, we start with defining assessments. We start with defining your right design models, understand the right production level. So just an example, we recently did a project in Netherlands, and this is a Dutch company. They are potato producers, and they were under tremendous pressure. And they've been our customers, Foxborough customers, for 30 long years. But now recently they had a pressure to reduce their reliance on gas. The goal was to install a new electrical boiler, like keeping the consumption under 10 megawatts, right? And then to compare the electricity bill with real values from the relays. So they completed all this exercise to manage, not just to maintain the threshold which is coming from the grid, but also to manage and ensure the electricity bill is maintained. They completed this exercise with Schneider by combining Aviva software and EcoStruxure power and process technology. They electrified the core process of boiler by using our unified control architecture. So this unified control architecture, this is the key factor which is very important at the operate stage of the life cycle, especially because this is where in the physical world, we are integrating both process automation system and energy management system with a hardware in between. It could be a controller, it could be a PLC. So we can do many such scenarios based on what is customers' preferences or what is the right approach. But having said that, the beauty of this architecture is that it doesn't impose one system's information onto the other. It makes sure that both the systems are coexisting, having like a dual citizenship. So information is passed along both the sides more seamlessly, more reliably, and at the same time we are able to manage the operational benefits and definitely keep on optimization angle towards our design scenarios as we move along. So I believe because operate and maintain stages are very different and they have a very different type of risk associated with it. Significant risk to uptime is not just because what an operator doesn't know, right? It sometimes is happening that one system knows and other cannot see. And that's the biggest challenge, because sometimes there is a substation, there's a trip occurs in substation, and that trip doesn't even reach the operator console. And what should have been a 10-minute reset ends up being a multi-day mystery because that trip never reached the operator control system. So how do we ensure that there is enough information for an operator, especially because they are the ones who's going to be defining in real time, making those decisions to manage, the influx of electrical flow of supply chain of electrons, to still maintain the production level. So they want to know in real time what electrical network can or cannot support. And it cannot happen if there is no way to manage information from both the sides in one platform or in one unified DCS system, which basically enables operator to make more informed decisions and prevent a lot of failures if possible.
Oh yeah, and why that's so important today, especially with all the workforce challenges, is that operator today is not necessarily the person with the 30 years experience. That operator may have just recently been hired, may have no experience in manufacturing, and those roles have been, as they've cut back, as manufacturers have cut down on the number of roles within the plants, that operator is probably multitasking, going from the control room to the floor, kind of taking kind of a combination of an operator and maybe even doing some maintenance at the same time. So they need to get that information gathered. They need like that single version of the truth, so they know what's going on the process side as well as the power side, and be able to have, and this is certainly leveraging tools such as AI, and that's also why it's important that these systems are, through digital twin technologies, can be simulated because you don't necessarily have the intelligence, the experience in the plant to be able to say, I could, based on my experience, you need to upsize that transformer. I mean, like in the days when we would, when they do like the factory acceptance testing on the, customers would come in and see the systems and then say, wow, I guess we should have made a change. Now you've wasted millions of dollars because you ordered something that doesn't work.
Exactly.
And the ultimate insurance policy is a digital twin.
Oh yeah. And honestly speaking, these are very inexpensive decisions to take during those design stages because it doesn't cost much, but these will become very expensive eventually if anything goes wrong down the line during the pure production stages. And funny you mentioned about this operator situation because recently I had a chance to talk to a customer who just got this electrodynamic controller for their brownfield plant, and they said, because we used to have trips very often, and every time that a trip used to occur, the engineer from our process side would carry a laptop, and then the engineer from electrical side would carry their laptop. They will download the logs, and then they will compare exactly, where is the root cause, what's happened. They will compare the time stamping, etc. But then they realize that, with the electrodynamic controller, you can see all the electrical information on the DCS with more time synchronized in a sequence of event manner. From weeks that they would spend, it come down to hours and days. So that's a huge savings for them, and a big risk factor being avoided by able to see or visualize information, as you said, at the right common source of truth, which didn't exist. It's important. And this is not even an electrified process. Imagine the complexity multiplies many folds if it's more dynamic in nature, with energy sources coming from grid, from renewable. The complexity rises so much, and if you still don't have a way to take or gain that data collection quicker and faster way, it's impossible. You really cannot reach that level of efficiencies.
Yeah, absolutely. I mean, I always think of kind of like some of the benefits I even see is like things like, just combining electrical asset data from even like motor control centers with production process and safety systems, and just putting that all together so they make better decisions. I mean, you improve interoperability, you improve safety, you improve flexibility, and customers are saving on their CapEx and OpEx expenses.
Yeah, absolutely.
And it increases production time. It increases efficiency, decreases unscheduled downtime, increases, KPIs like overall equipment effectiveness. I mean, we see that all the time. I mean, it's such a catalyst for, digital, helping people advance with their digital transformation journeys, because it's enabling IoT, cloud, edge, advanced analytics, obviously, as you mentioned very clearly, with digital twin, even solutions such as augmented reality and virtual reality to kind of help them do their, to kind of help them understand with work processes of, how do you maintain some of this equipment on the factory floor by having, work processes through a wearable to kind of guide them through that process. And the ability, and with AI injected, kind of, embedded in many of these solutions to kind of give them that co-pilot type of information to kind of help them, step by step what they need to do, and to be able, with large language models, to answer a lot of their questions. Yeah. I mean, it's really, it's really like the perfect time the perfect timing for this, where I think technology has caught up, and I mean, and you think about it, as you move in a world with between software defined automation and open standards like IEC 615 499 for open standards. I mean, it's just so critical today. But as we begin to kind of wrap things up, do you have any parting thoughts that you have for our listeners today?
Well, I think it's quite simple. Like, in today's world of changing industrial landscape, sustainability and efficiency is not optional. It is expected. So it's now an expectations to really make that impact, to really not just survive, but also innovate and definitely take advantage of technologies like you mentioned, software-defined automation, AI, and this kind of an integrated approach to redefine their processes. This is basically, I would not even say it's optional anymore. Really, it is expected. Mm-hmm. Yeah, absolutely.
I think it's definitely mandatory, and that's certainly what we've certainly been writing about at ARC. But Manishi, I can't thank you enough for being here today. It was a really insightful discussion, and you're going to certainly. I look forward to continued dialogue and hearing about additional success stories and seeing where technology continues to take you and Schneider Electric. So thank you so much.
It was my pleasure too, Craig, as always, to talk to you, and thank you so much as well. It was very insightful discussing with you.
Again, thanks so much. And this is Craig Resnick from the ARC Advisory Group. Thank you so much for being with us today. Thank you. Have a great day. Bye-bye.